All right, this is Aaron Murakami with this live EPD call with we're going to have Griffin Brock and Adrian Marsh from the UK with AM Innovations, and Hakasays has been on the road, so he hasn't. I don't think he has any updates to share, so he's just hanging out with us. Justin has a few things. Bruce Gavin, I don't know if I saw him come on. He may or may not have something, but we'll be opening up for questions. This call is being recorded and it'll be put on YouTube as fast as I can get it on there. And as long as the whole call is appropriate, I'll just slap on a beginning and end screen, upload it. I'm not even going to bother editing it. And so today is February 17th, 2024. It's noon Pacific time. And Eric's website is ericpdollar.com. Let me do a screen share here. It is a 501c3 nonprofit registered down in Nevada. And do screen share real quick. So right here at ericpdollar.com, a lot of the efforts going on with a lot of these projects with just EPD Labs collectively and so on are supported by a lot of the donations. And all donations are tax deductible. Every bit helps. On ericpdollar.com, you can click this donate button right here. And then if you scroll down, there is a PayPal link. This is a way where you can donate easily by PayPal. And I believe that there's a recurring option. If you want to have $5 a month automatically going to EPD Labs, $20, $50, you know, whatever. Most donations do come in by PayPal, and those go to the projects that we're going to be talking about and sharing on this call, and in ones that you see in previous calls. Those are supported by all the help collectively from everybody who wants to see this kind of thing move forward. I hardly ever mention this Bitcoin link. It's because I haven't gone into there for years, and I just had it verified that there's actually a couple $100 in there. So that's better than nothing. And if you're into the crypto coins, here's a Bitcoin link and a QR code to donate directly to the wallet dedicated for EPD Labs. And then if you want to send a check or money order, you can make it payable to EPD Labs and send it to this address in Spokane. And then I just endorse those and send it down to the bank in Tonopah, and that helps to cover bills, insurance, parts, you know, some travel, you know, to where we can have these collaborative get-togethers with a lot of the guys that you normally see on these kind of calls. And then his website is also has a lot of resources. There's, you know, some books, videos. There's a bunch of free videos, papers, a lot of photos. Griffin's done a good job at kind of keeping it updated on some of the projects that you can kind of see on the blog. You can scroll down and see a long history of a lot of the stuff that Eric has been involved in. I want to mention emediapress.com, which is my main website. And this is where the conference presentations over the last 12 years are all posted. You can just kind of scroll down. These are the ones from 2023 conference. Last year in July was the 12th annual Energy Science and Technology Conference here in Spokane, Washington. Last 2 years, we actually had the conference at my shop. And it's jam-packed with not just a lot of presentations, but we're showing there's a lot of demonstrations that are shown to everybody that you're really not seeing anywhere else. And so I'm very confident in saying that we're at the cutting edge and are doing things that nobody else is showing online anywhere, demonstrating. And so we're really kind of at the forefront of a lot of this kind of research. And again, a lot of those donations go to these kind of projects, and then we do the presentations, make those available so you can learn more about them. It's undecided if there's going to be a conference. I'm kind of playing with different ideas of how to bring a more product-oriented kind of thing to the conference, or at least a part of it, because a lot of the presentations talk about different technologies. And what I believe is that people want to be able to just put them in their hands. And I'm considering just taking off this year for the regular conference so I can get 3 or 4 products into production, and then maybe have some type of hybrid conference next year. But there is a lot of parts at my conference with a lot of the presentations, for example, like what Eric and Adrian was doing. And so there's some unfinished business there with some of those projects. I'm not going to look for the videos relevant to show you the pictures. They're all in here. And you can just, use a product search here, or you can search for in the shop by the different year, and you can find authors and all that. So, there's a possibility there might be like a high voltage, high frequency, Tesla oriented type of get together with maybe like a 3-day, intensive workshop, something along those lines, where all these guys kind of come and we do a lot of these things, remote presentations. And so all those things are going to be coming down the line. And that, I have a couple forums. I just want to show energeticforum.com real quick. And so in the Energetic Forum, Eric knows how to log in here by himself and reply to people and make posts. And so we had posted all the stuff for the Colorado Springs presentation and all that right here in the forum. And if you are interested in directly communicating with Eric, instead of emailing me and asking me to send him a message, well, first of all, Eric doesn't do email. I would have to call him up, and I'm not going to call him up to read him everybody's email. If you want to write him a letter, that's the address is on ericpdollar.com. You can find the address down in Nevada where you can write to him, and as long as it's not some crazy letter about UFOs and abductions and whatever, you'll probably get a handwritten letter back from him. But if you want a quick answer, and if you want to engage with Eric directly at any time, post in this forum and make use of that, because I'm going to be updating this forum. There's an Eric Dollard forum. Go in there, post in the appropriate area, and Eric can respond to you directly. That way, I don't have to be a middleman. I'm not the messenger. I don't have to deal with all that. You can just talk straight to him. Registration is free. You just go to energeticforum.com, and at the very top right, you can register. Each membership does have to be manually approved. And so just email help or email info@emediapress.com with your username and your email, and I will approve it. Therefore, you'll be able, and then you will be able to see the attachments, and you will be able to also make posts. And I would recommend emailing me from the email that you actually use to register, because a lot of people will email, a lot of people have multiple emails. They email me from an email they didn't register, and then they tell me, oh, they can't log in. And they don't even give me a username. So I look up the email, and it's not even in the system because they use an email that's different from the one that they're emailing me from. Email me from the email that you registered. Okay. So are there any scheduled events or anything like that, Eric, that we should mention, as far as other than the next call, which might be in about, a month, roughly in the middle of March?
Well, it's still kind of up in the air yet, but I think we pretty much have it figured out what we want to get done.
Okay.
So one thing is to get the backbone of the Alexanderson antenna that's going up out on the right of way on the internet. The only problem is that will incur another communications bill. So I'm not certain if it's a good idea to have another bill come in right now, because input just equals the output, so to speak.
Okay.
The other thing is to get telephone and power out at the seismograph mine.
Okay.
That will also incur more utility bills, so that may not be affordable, but at least we can get the physical layout done. So, and possibly to get to reach 2 steps here at the building is to get the TCS transmitter reconfigured for the operation we want, and get the Tesla transformer on the air continuously on the frequency of 1999 kilocycles per second, the power of 100 watts. So that has a very high priority. I think that one we can get done probably by this summer. And then we're going to try to get the first stages of getting some electrical system here in the building, so that at least there's outlets to plug things in. There's virtually nothing now. And that will incorporate the Tesla 4-phase system. So somebody donated $1,000 that was put in towards the transformer necessary for that, the 208 to 120 volt, 7.5 kVA transformer. Another group donated $3,400, and that will go into installing the electrical service at the mine. I'm not sure what the utility companies going to want to charge for this, but they did an awful lot of work for free so far and have been very cooperative. So that's basically what's planned for this year.
Okay. Justin, do you have like business stuff that you wanted to kind of cover on any EPD stuff? You said you had a few things to share before we start getting into all the technical stuff, or?
Yeah. Hi, everybody. Thanks for being on the call. It's good to see all of you here. And I'll just kind of reiterate, maybe clarify some of what Eric was talking about. We have, as I've presented before, as Eric's presented before, there's a number of open aspects of the projects that we're doing physically around the lab, the open wire line, the seismograph mine, and also the building itself. And so Eric just kind of touched on a few of those different items. We've got some plans. We've got some ideas in the works of what we want to do next. Exactly how we're going to go about that is still sort of up in the air. And as Eric indicated, we will need to figure out what the costs of these things are going to be and what the level of interest is so that we can fund the next phase of the operation. And as we go along, we're reaching a point where we can really start to do a lot of documentation. So one of our hopes for an upcoming episode is to do a really serious documentation and present to the audience online exactly what it is that we have, what are the facilities, what's the status of them, what's the purpose of all of this equipment, what's needed to implement all of this, and then what do we intend to do with it once we've got it to that state of completion. So we're right there. We've made a lot of progress in 2023. And we also have the strength of this collaborative group that you see here on this call. So now's a perfect time for us to take that up and really show the whole scope of what it is that we've done to this point and what it is that we're in possession of that's so very unique and worth funding. So with that, that's kind of a general overview. I'd be happy to answer any questions on that, but otherwise I'll just yield back to the group.
Okay. Let's see. And also I want to mention in the chat, a lot of times people will post questions in the chat as we're going along. It's hard to roll back through those and answer those questions. And so if anybody does have any questions, usually we can just open up kind of at the end and just have an open Q&A. And then you can just introduce yourself, what you want to ask, and who you're directing the question to. So Eric, do you want to go into any of the kind of technical stuff that will segue into what Griffin's bullet points that he'll be covering?
Well, I'm going to kind of start with an overview of where things are at and where I'm at, and then that will lead to what Griffin's working on. So basically, I want to point out what these episodes that we're presently engaged in are about. We're orientating this towards an audience that builds things and is interested in diagrams and seeing, how many terms to use and what have you. What we're not interested in, and we will not waste our time on, is whirly-twirly theories that prove Einstein is fine. I have no tolerance for that. I don't want to hear any more questions answered on all these wild theories and speculations and far out stuff. It's a waste of time, and all it's going to do is make me mad. So some of the comments are, that I've read is people, they're all belligerent that, we want our free energy secrets and you're too technical and all that technical gobbledygook. Well, my recommendation to those people is don't involve yourself in this and go back to your favorite episode of Sesame Street. So same thing with the free energy secrets and 0-point energy and the triple Bravo bovine shice of Bedini-Bearden scalar wave. No, not here. None of that. There isn't any of that. The only thing that even nearly relates to that is the Trump motor and the Tesla turbine, which is an exceedingly complex project that requires people with very special talents and large quantities of money. which is undergoing. So one thing that I want to start focusing more on is the discussion of what we call gangrene energy, which is getting out of control. And nobody seems to have a straight answer of what's going on. There's all kinds of wild conspiracies that could develop out of it, but not being interested too much in the conspiracies, I just want to point out what's going on and all the basically misinformation and confusion. And basically there's a simple rule of thumb when you view anybody presenting on this subject. If they use the word EMF, that is a direct indication that they have absolutely no knowledge of what they're talking about. EMF means electromotive force. They use as an abbreviation for electromagnetic field. That is not proper technical terminology. EMF is EMF. You can't make up your own things as you go along. And point that you don't know the subject you're talking about. It's what's called electromagnetic interference or electromagnetic radiation. In our realm, it's electromagnetic interference because what it's doing is it's making it impossible to do any earth sensing or radio reception, and the jamming has gotten completely out of control. So basically what I'm working on here is writing up my last two presentations, which basically involves polyphase sequence theory, which is of course directly applicable to Nikola Tesla, and lesser known is directly applicable to the music of Johann Sebastian Bach. So these write-ups normally take about 2 years. So the diagrams for the Bach music involve about 100 pages. I managed to get about 2 of them done per day. I can get 1 page of the Tesla polyphase analysis done in every 2 days. So I don't like hurrying this stuff or taking shortcuts. It's best to go very slow and methodically and think each word out to make this stuff understandable to people with a minimum amount of technical knowledge. And then the situation here, unfortunately, is even though we do have all this outside plant and we are a public utility in this particular district and have a material inventory that would classify this place as standard surplus, there's still no laboratory. There's no way to really work on anything here. There's no power outlets. There's no light. There's no shelves or cabinets or walls to put this stuff on or any of that. So the best I can do is the writing, which I do every day, 7 days a week, as I've always have, and turn the material or physical development part over to Griffin, who's very adept at this. But then, of course, he is only one person and only has so much time, but we're making good progress. We have a number of audio amplifier circuits developed. And the only thing that's lagging it right now is I'm not able to get the proper test results before money is expended on custom ordering the specialized transformers that are required for this type of development. There are a number of other things going on similarly that basically what we're doing is we're kind of becoming a second generation of what was called, the company was called Wireless Specialty Apparatus Company. And they made all the condensers and coils and switchboards and everything in the Marconi days up to the point at which Radio Corporation of America absorbed them. So we're kind of doing a similar thing in that the tubes that Griffin's working on and the engineering aspects of Adrian's work and amplifiers and oscillators and modulators that are being developed are basically the fundamental components in doing this type of so-called Tesla research, duplicating his work, which essentially nobody else is doing, even though everybody smears, their name all over Tesla. There's really very little going on with Tesla, but we're actually, the Tesla tubes, the Tesla converters, all this kind of stuff are all undergoing. I'm designing this stuff along with Griffin, and Griffin is building this stuff. So probably the most advanced element of this is the vacuum tube research, which Griffin had initiated and developed, and which I've been advising him on. And so there's a series of vacuum tubes that will be studied. Right now, Griffin is working on the 1A21, which is the fundamental Tesla radiant matter tube, so to speak. And then there's the 1A22, which will be a version that has a small amount of inert gas in it. And then there'll be the 2B45, which will be a quite fascinating tube that will involve elements extracted from color TV shunt regulator tubes in the envelope, evacuated envelope that Griffin has developed for generating these rays. Now, probably the most interesting thing that's come out of this so far with the 1A21 is the problem is only has a life of 30 hours. In order to be commercially viable, it has to have a life of 500 hours, at which point it will be the 1A21A. The problem we have is what's called cathode depletion. After 30 hours, the cathode no longer radiates. So there's a couple of ways of looking at this. If this is a radiant matter tube, well, then the cathode is being radiated and lost, but when the cathode is subject to analysis, it's found that there's no change in its molecular consistency. It's still aluminum, has not lost any mass, but it loses something. And once that something's gone, it doesn't radiate anymore. So this really kind of opens up a can of worms in physical science as to what's being radiated and what's being lost. So Griffin is hashing this out. It's a very arduous, tedious process to do this. So it's been going slow. So that's where we're at now with that. As far as the 2B45, Griffin is working on implanting the transplant element from the color TV tube into his vacuum tube structure. But that's easier said than done, because you cannot weld two different species of glass together, because when the stuff cools down from being red hot to room temperature, the thermal expansion coefficients cause the glass to crack, and so you have to bust all the glass away on the stem and make a new stem, and then you have the vacuum seal process. So this has been another laborious, tedious advancement in this, but I feel quite confident that Griffin will overcome all these things. So in the long term, there's still the 0A1 cosmic light bulb that Aaron has the radio frequency equipment to power. There's also the possibility of, from the wireless specialty apparatus point of view, of making the 1B22 radar modulator tube available again. It's simple, fairly easy to construct, and if there's enough experimenters that are interested in acquiring that tube, we could go into the manufacturing process or farm out the manufacturing process, because the supply of those tubes, which were developed by Bell Telephone Laboratories in World War II, is depleted and they're no longer available. So I think at that point, I believe I've said all that I want to introduce into this. Your sound's off, Aaron.
Do you want to go straight into Griffin's bullet points, or?
Yeah, because Griffin
Okay.
and I have been working on a lot of things, and he may have some significant comments and actually some working stuff, and then
Okay.
we can talk about that.
I just want to make a quick comment that a lot of people emailing me and stuff lately, I've been slow getting back to them and that kind of stuff. There's some personal family emergency stuff, and attorney business and thing that I've been dealing with, and that's kind of taken priority. Haven't been at my shop. I apologize if I haven't been getting back to your emails as fast as I can. For the most part, I haven't even been at the shop. Plus, the furnace was shut down for about a week because we had some B-25 bomber oil from an airplane in an old museum. It's not flammable, and so we've been freezing out there. So I just want to let you know we got that going, and I'm in the process of catching up on a bunch of emails, getting back to people. There's a lot of things on the to-do list that I got to get back on, projects and stuff. So I apologize if you haven't received an email from me and you've been asking questions. So I just want to say that. So go ahead, and Griffin, if you want to. It's all you.
Okay. Here, I'll start sharing my screen. So before I do, I'll mention that what I'll be covering is primarily going into what Eric had mentioned previously regarding gangrene energy, and that regarding the Tesla converter. Let's see, it says that you've disabled screen sharing.
I see you fine.
Okay, there we go. Can everybody see?
Yeah.
Okay. Okay, to start this presentation regarding the Tesla converter and gangrene research, we will cover the parameters of the setup. So as shown in previous live calls, as well as on my website, I've constructed a type of electrostatic receiving antenna that comprises the form of what is known as a Marconi flat top antenna, except that it does differ in many designs. So what makes this antenna unique, other than its compact shape and granted the limited space that I'm operating with, is that as opposed to operating as a conventional Marconi flat top antenna, which this is an original photo of from the mid-1910s, we are not using individual wires, which are shown here placed parallel to each other as individual conductors, but rather as a concatenated antenna that operates merely as a capacitive sheet or a large metallic surface. So rather than isolating these wires, they are all combined, and this comprises the elevated capacity, which we will be using for the Tesla converter setup. Now, the Tesla converter, as some may be familiar with, was classified as the Tesla radiant matter collector, which was showcased in a couple of Tesla's patents. It's a rather simplistic design. We could see here that there's an elevated plate, a buried earth terminal, a condenser, which goes across the two, a circuit controller, which is essentially a switch that has a specific rapidity of opening and closing, and that combined with the condenser, along with some other components which aren't shown in this specific schematic layout, forms a type of time constant and a discharging rate, which when combined with a transformer is able to magnify the switching transients, which are essentially collected off of this elevated capacity plate and can be delivered to any receiving device. Now, this coincides with some of Tesla's early lightning detectors, which in the case of a load, he would actuate a bell that would be essentially switched by a very sensitive relay. But in this case, we'll be using this type of converter not for lightning detection, but mostly for the receiving of natural telluric activity. Now, talked about in previous live calls, the main error or the main trouble that we're experiencing with the current setup that I have is the proliferation of radio frequency interference, which is not making it possible to receive the natural telluric activity. So in doing so, we have to take other methods and use different procedures to measure this activity. And one method is to use the circuit controller and effectively receive below 30 cycles per second. Now, one thing that I want to point out in this apparatus and this overall scheme is the circuit controller. Now, Tesla speaks of using the circuit controller via a method of a cogwheel and clockwork. So essentially, we create an electromechanical device that's able to switch on and off at a rapidity of 27 times per second using a mechanism that is rather similar to this, which I had constructed previously to experiment with Tesla's original design. This is a rather tentative setup, but nonetheless, it achieved the same. But instead of using this bulky apparatus, which is prone to severe vibration as well as noise, we are using a rather special electromechanical apparatus that's able to achieve the same, but also the rapidity of the braking can be greatly varied with significant ease. Now, in using this electromechanical device, we could obtain interesting results, specifically in the preliminary experiments that I've conducted with this type of circuit employing the Marconi flat top antenna. I've obtained the following oscillograph, which essentially shows the switching transients as well as the overall output of the system. Of course, this is a very preliminary observation, as I have not yet had a chance to fully dwell into the configuration of this Tesla converter, but nonetheless, this displays the overall characteristic of what we're trying to achieve. Now, in relation to the nearby sources of radio frequency interference, which are primarily generated by nonlinear loads such as compact fluorescents, LEDs, and what have you, this oscillograph will greatly vary in terms of shape and character over time as surrounding nonlinear loads which generate this unwanted radio frequency interference. It will manipulate the waveform shown, and in an overall depiction of what could be detected with using the flat top and excluding the Tesla converter, we could obtain this type of waveform, which I want to point out primarily depicts just the overall variation of said interference, which is generated within my surrounding environment. Now, keep in mind, this waveform is highly susceptible to nearby AM radio broadcast transmissions, specifically two of which operate in the upper part of the AM broadcast band and are unfortunately located only 4 miles away from my location and typically broadcast at a power rating of about 50 kilowatts. But nonetheless, this waveform, which is essentially the raw output of what's being received from my ionospheric flat top antenna and that of a decent ground termination, shows how nearby radio frequency interference is able to manipulate the receiving that we are trying to achieve and how this becomes highly susceptible to this interference. Now, unfortunately, I do not have an oscillograph or a depiction of severe waveform dampening and manipulation from this interference, which I've recorded at different parts of the day can become quite severe and severely dampen the waveform. This interference is essentially very difficult to filter out. As Eric was pointing out, it has become a significant problem in the overall scheme of electrodynamic seismic forecasting, as well as simply natural ionospheric or telluric receiving experiments. So this is one thing I want to point out, which has become a significant problem in light of, I would say, only recent time. So luckily, this problem with interference is nothing, I would say, related to the transformer configuration of my local utility system. Granted, within the San Gabriel area of California, the local utility company is still employing a Y primary and delta secondary and has not, thankfully, retrograded directly to a YY configuration on both the secondary and primary, as is the case in many other places around the globe and around the nation. So that does provide some form of isolation from the interference, but nonetheless, that does not stop the production of interference as produced by neighbors and other facilities within my area. So as time progresses, I would say within the next week or two, I will be providing more detailed information on just the general scope of the proliferation of this so-called gangrene energy and overall interference, as well as the detailed analysis of the Tesla converter, which will be employed in the electrodynamic seismic forecasting setup, which I'm currently constructing and perfecting. Now, going into other experiments that are involving the Marconi flat top antenna, as was shown prior, I have taken up the liberty of experimenting with the various Coherer receivers that Nikola Tesla had pioneered at the turn of the century, as well as the late 19th century, specifically at Colorado Springs. So what you are seeing before you is an example of a perfected Coherer receiver, which Nikola Tesla devised in 1899. It employs the receiver element, which is labeled as A. It's a rectangular figure, as well as a resonant tank setup, which effectively magnifies the received signal from the Coherer, as well as other elements of the setup, which form a rather unique receiver. One thing that Nikola Tesla had found with the receiver, which was the predecessor to the Galena cat's whisker detector, which soon followed, as well as vacuum tube receivers, was that unlike Marconi and other contemporaries, Nikola Tesla had used the Coherer in a rotating manner, where the Coherer was mechanically rotated rather than being actuated by a physical movement to decohere the filings within the glass ampule of the Coherer. Now, from what I've gathered over my recent researches, is that no one has effectively constructed a replica of Tesla's rotating Coherer receiver, which is rather surprising, as it is quite simple, but also should yield some interesting results. And granted that the fact no one has replicated such, I've taken up the liberty of constructing, I would say, a rather experimental setup using the rotating Coherer concept. Here is a very tentative design. It is far from perfect, of enabling a rotating Coherer, which is essentially rotated by a small motor that can be supplied by either a battery or an external alternate DC direct current source, which is shown on the right, rather than using clockwork, which would have to be wound every couple of hours and is quite bulky. I've taken the liberty of using a small mechanical motor. And the difficulty in engineering this type of setup, despite its crudeness, is to effectively maintain a continuous electrical contact with the Coherer while it's rotating. Now, this rotation may be varied by varying the applied voltage to the motor. So I could have effectively obtained a rotation of about 20 to 40 rotations per minute. Nikola Tesla had determined 27 rotations per minute was ideal, but nonetheless, this is up for great experimentation. Now, at the present, I do not have a decent photo of the setup, as it's quite primordial, but nonetheless, when I've used the setup as outlined in the prior schematic shown here, I have recorded lightning strokes and the sensitivity of the receiver at a distance, I would say, of about 100 miles. So this is highly dependent on natural lightning activity, which of course does not always occur when you want it to. So I have to rely on various lightning stroke indicator websites, which describe or show a live depiction of when lightning activity is occurring around the globe. And from that, I've been able to deduce that this receiver that I've constructed can effectively receive strokes from around 100 to 150 miles, but that's highly tentative. And of course, the actual detailed analysis of the receiver, its sensitivity, and other variations of it still have to be determined, so that will, of course, occur in due time. But nonetheless, this is what has been occurring in the realm of experimentation with regard to the Marconi flat top antenna and electrodynamic seismic forecasting as a whole. I am currently working on other experiments that are not directly related to this, as Eric had pointed out previously, including the Tesla oscillator, which is an improvement and a replication of Nikola Tesla's oil-filled oscillator from the early 1890s, as well as the perfection of the 1A21 Desmatron tube and other experiments associated with it. So that completes my presentation, and I could hand it over to Adrian.
Thank you, Griffin. I'll just share my screen. Is that, do you see that, Aaron?
Yes, I can see it just fine.
Okay, good. Okay, so what I'm going to be presenting today, I'm going to give an update on where we've reached with the Golden Dragon research. For those that didn't see my presentation last year at ESTC, the Golden Dragon research, or the golden ratio discharge, is as important fundamental research as it's about revealing the underlying natural order of electricity and what might constitute electricity at a deeper level. And in that respect, it makes it a very interesting research area. It's something that's not really readily pursued out there in the world. You're not really going to find this kind of research anywhere else. This is something that we're doing all together in conjunction at EPD Labs. And Eric and I are currently working on the beginnings of a design of a 20 kilowatts GU5B push-pull amplifier, power amplifier, which is most likely going to allow us to take this research even further.
Adrian, did you try to enlarge the picture? I can see a little blue circle by the mouse pointer, but it's still thumbnail size.
For me, it's showing full screen.
Does it show full screen for you, Eric, or
No,
Griffin?
no.
It's thumbnails for you too?
I think it stopped updating.
It froze.
I'm gonna stop sharing and just share again.
Okay.
Just
Okay. There you go. Now it's big.
okay, you see that, Aaron? Okay. All right, good. So I'll just recap, since I haven't given an update on this for a while. I will just recap on the basic equipment that we're using, and then I'll also come on to talk a little bit about the design that Eric and I are currently working on. So this is in my lab in the UK. This is the primary experimental apparatus that I used for the golden ratio discharge and the golden drag, or essentially the golden dragon. I will explain this. I used a similar setup in ESTC both 2023 and also at 2022. Actually, the coil unit on the left is actually the same unit as I used in 2023, although the coil is different. There is a daughter coil, which is essentially at Aaron's research lab, and this was the original coil that I built in the UK. So going from left to right, this is the coil unit. It's a Tesla coil, nominally with its center frequency around 3 megacycles. It's designed for high voltage magnification. It's a quarter wave coil on the virtual ground plane. You can see the metal ground plane on the surface. And there is a large vacuum variable capacitor for tuning, where you can see the rotating knob at the front of the box. And this system is being driven overall as an auto-tuned power oscillator. So you'll see on the left, this region here, there is a feedback coil that is feeding back a proportion of the output of the Tesla coil as positive feedback to the GU5B tube, which you can see in the middle there. And This unit at the center here, this is a single GU5B power oscillator with everything in there involves the to power the tube, including the filament transformer, various meters. We're using the old style Western 425 thermometers to measure things like plate current, grid current, and also down on the left there, cathode current. And then on the right, we have the power supply. This is, I'm going to go into a little bit more detail. This is nominally a 5 kilowatt continuous single phase. You can do that in the UK because the line is essentially 240 volts, 50 hertz, and you can pull up to about 35 amps on a single phase in the UK. So that makes it more than adequate, even with the power factor correction. It makes it more than adequate for a single phase unit of that power. Now, the power supply that we'll be using for the new project for the push-pull GU5B will actually be a 3-phase unit. So that will obviously have its own benefits being 3-phase, but currently I'm using a single phase unit. I will show that power supply in a little bit more detail. Now, what I'm going to be looking at here is I'm going to be looking at cathode modulation. So this was continuing work from the work that Eric and I did at ESTC, both early last year with the hybrid and the ESTC and after, where we had a hybrid unit from the power oscillator that I have at Aaron's lab, and a combination of the RF and the audio rack that Eric has designed and has been constructed by Aaron and others that we were working on last year. So that was the hybrid unit. And into that, Eric brought cathode modulation. So that allowed us to do a range of experiments, both with the golden ratio discharge, with the hybrid, and also with the burning bush, and the various modulations that and the different types of the tree and the roots type of discharge that came out of that. So taking that on further back in my own lab, I decided to add cathode modulation to the system, as I hadn't explored that up until now. And I undertook two different types of modulators. So I'm going to show those, and I'm going to go into a little bit more detail of the system as well, so we can see what's there. But this is the overall apparatus. It's a research apparatus, so it's basically designed for short runs. It's not the type of system that is designed for continuous usage. So this is a little bit more detail on the GU5B unit. It's a single GU5B mounted upright. So this is the anode at the top. The cathode obviously into the bottom of the box, and also we have the toroidal filament transformer in there and all the other necessary wiring for the grid feedback. I think there's an open view there of what's inside the box. Again, it's constructed as a research unit. It's not intended to be a final unit. One would construct this as a final unit within a metal rack, and then put that with several other units, including the power supply. So here we can see some of the finer elements. We can see the mounting of the tube in its chimney. It has a turbo fan underneath there. That turbo fan is designed to deliver in the region of just over 200 cubic foot a minute, and it has variable speed. So 200 cubic foot a minute from a fan that size is fairly noisy. So when you're actually just between runs, or you're setting sums up or measuring, then you can turn the speed of that fan down just to an idle speed, and then that just keeps the tube at idle. And then when you want to actually run, then you can turn that up full, and you get the necessary cooling that's required to actually keep the whole thing cool when you're running at very high power. This system is capable, I will show discharges which are pushing an peak envelope power of around about 10 kilowatts. You can see now in the tube unit underneath, you can see the large KP14 vacuum variable capacitor. That's a 20 picofarad to 1000 picofarad variable capacitor in parallel tune with the primary. And that allows us to adjust the various, the two parallel modes that this system is running on. So this system can be switched between the lower parallel mode and the upper parallel mode, and the resulting different types of discharge that you get as a result of that type of tuning. Okay, this unit at the back here, let me just go back one stage. You see that there is this is now directly from the output of the power supply. There is a large pulse capacitor there. That's a 25 nanofarad, 25 kilovolt blocking capacitor directly between the coil system and the power supply itself. And particularly for the modulation, that's actually very important to protect the internal components of the power supply. And I'll come on to the reason for that in a minute. So going back to there, we can see basically it's a simple pass-through. So on the right is the final output of the power supply. And that is basically fed through across the capacitor. There's a spark gap on the coil side of the unit, and then the final output, which drives directly to the high side of the primary. Now, the reason that we have this here is because when we are using, for example, there are two types of modulation. If I go back a stage, first of all, and talk about the kind of waveform that we are getting out of this power supply, essentially we are getting a very high power level shifted sine wave. So if we imagine an ordinary sine wave, high voltage output at 50 hertz, and then we level shift that all positive, or almost all positive, then what we end up with, we can imagine a sine wave there, which is shifted upwards. We have an increasing ramp on the positive side of the sine wave, a decreasing ramp, and that is essentially the point at which we energize the primary coil. Now, if we're going to cathode modulate this, so in other words, we're going to switch the lower end of the tube, then if we don't do that in synchronization or in sync with the change, with the variation of that, then we could open ourselves to some very nasty transients in the system. Now, this system is also designed to allow large transients because it's a research system. It's not the kind of thing that you would use on if you were using it for example, an always-on amplifier or an RF amplifier, but it is designed to allow large transients because the transients have very interesting effects on the discharges. So we could, for example, if we were using it as a linear power amplifier, we might imagine having a high voltage choke there, which would also be an effective way of being able to protect transients backwards and forwards between the power supply and the coil system. But in this case, because we actually want transients from switching in the power supply, then we would effectively remove those by using a high voltage choke. So the scenario is if we energize the primary, and if we were then, for example, to open the cathode at the wrong moment, we suddenly have an enormous amount of energy stored within the primary, within the Tesla transformer. And that energy has got to dissipate somewhere. So without this protection device, without the spark gap there, it's going to produce some very horrendously large voltage transients, which are going to go right back into the power. It's the only place it can go since the cathode is open. It's going to go straight back into the power supply, and then it starts blowing things like rectifiers. The control circuits don't work correctly, all of those kinds of things. But if that happens, then basically the high voltage is caught by the spark gap. So there's I believe, a better view of that. No, I didn't have a better view of that. Okay, so this spark gap here is set to about, the tungsten electrodes, they are set to about 5 millimeters in gap. And that is enough so that it doesn't arc over in normal operation when even at peak envelope power, but it is enough if you get a transient kickback from the coil. So in other words, if the cathode opens at the wrong time and you don't, that means that if you are using the type of cathode modulator matters. So if you are using semiconductors to do the cathode switching, then you don't end up having to have a very large bag of semiconductors. Semiconductors don't like high voltage spikes at all in the system. And often when you're using modulation with semiconductors at the cathode, then if you happen to time it incorrectly, or the oscillator stops oscillating when you didn't expect it, or the tune goes out for some reason because you are adjusting or trying something new, then you end up very, very easily blowing the semiconductors in the cathode. So this actually prevents that process from taking place, and it's surprisingly effective. So moving on, I'll show, so this shows the other side. So now we can see the feedback coil with its adjustable taps. So here we can select the optimum level of feedback for the power oscillator. And also we have our Western 425 thermoammeter there, which is also measuring the current directly, the cathode current directly out of the bottom of the Tesla coil. We can calibrate that using this high power adjustable variable resistor. So this is all calibrated to, it has an internal impedance of about 1 ohm or so, and that allows us to extend the range of this meter from 1 amp to 2 amp. It's just using a resistive shunt across the meter. Again, another view of the variable capacitor. And this is the power supply. So this is the insides of the power supply. We notice here the transformers. I'm actually using four industrial microwave oven transformers. They're 1.8 kVA each. Originally, I had 2 inside, but in order to increase the overall output power of the system, I added 2 additional. These can be arranged in series or parallel with each other via this patch board. What you can also see here is aspects of the level shifter, the SCR control. This can be controlled 2 ways. The overall output power can be controlled with a variable, with a variac, or it can be used with an SCR. The advantage of the SCR is it produces some very wicked switching. So it produces some very wicked transients, which again also produce some very interesting effects in the discharges as well. I think I've covered much about this power supply before, so I'm not going to say too much about that here. There's also a lot on this on my website at aminnovations.com. I go into the design and detail of this power supply, and I've also previously presented it at other live calls and also at ESTC as well. So let's move on to the modulation. Here's just before we do that, there's another view here of the transformers. We can see it more clearly, and the patch board, and this unit with the vacuum relays along there allows us to switch from various measurement ranges. We can measure the output of this system from 5, 10 kilovolts and 20 kilovolts. When we attach these various transformers in different arrangements with the doubler, we can get some very, very large voltages out of this. So peak voltages can easily hit somewhere around about the 10 to 12 kilovolts. That's what makes the GU5B such a wonderful tube for this. Is one, it readily wants to oscillate, and secondly, it seems to be exceedingly robust to periods of peak power and peak voltage on the anode, far above its ratings. This tube that I've been using here, it's the same tube that I've been doing this for years and years and years. I've never actually blown a GU5B. I have blown other tubes on this, particularly the 833C, even a pair of them was too much plate power, too much dissipated plate power, but the GU5B just doesn't seem to have a problem with those things. So it is a very good choice of tube for this kind of research experimentation, and also the reason why Eric and I base the push-pull, the even higher power push-pull design around a pair of those tubes. To give you a perspective of the transformers involved, so the transformer that you see here is the center transformer. So that is a 1.8 kVA microwave oven transformer. To its right is a smaller 900, that's about 900 watt standard domestic microwave transformer. Nominally, the output voltages are the same for these. So it's about 2100 volts RMS, 3000 volt peak. And on the left here, to give it some perspective, is that that's a 10 kVA transformer, which is intended, I haven't rewound it yet, but is intended to be rewound as a high voltage transformer. So it's effectively almost 1/2 of a pole pig in one transformer. It weighs 50 kilos, and it's quite fun just even to look at it in terms of size. But this will be delaminated, the outer windings will come off, and I will wind that as a high voltage transformer to give in the region of about 8 kilovolts at 10 kVA. So that gives some perspective. Okay, so let's have a look at the modulators. So let's take this view first. So this is a semiconductor solid state relay. It's what's good about the solid state relay is it involves zero crossing detection. So what that means is that it only switches the output triac when it detects voltage crosses zero. And that's very, very good for the semiconductor because it means it's exceedingly difficult to get it out of sync with the waveform. So if you remember that we have a level shifted sine wave, which with a peak, say an upper peak voltage in the region of about open circuit 12 kilovolts, and the lower section is not fully level shifted. So in other words, it will go somewhere in the region of about 500 volts below zero. And that gives us ample opportunity to use zero crossing detection. So that means that we can properly sync the switching of this to the rise, or so the rising edge of the sine wave or the falling edge of the sine wave, bearing in mind now that it is level shifted. So therefore you can energize the primary for almost twice the time because essentially it is level shifted. And so using one of these, I found it surprisingly difficult to actually blow one of these devices. I have been through a couple when I was first experimenting how to set them up, but otherwise they are surprisingly robust and they're readily available. I mean, these are the kind of relays that are used for switching single phase and 3-phase motors in very common machinery here, like lathes and milling machines and things like that. So they are a readily available modern component that can be switched from a low voltage. Inside they have an opto oscillator, which also has zero crossing detection, which switches a triac. And that triac then is sufficiently powerful to be directly in the cathode, the ground, or the cathode to the negative end of the power supply, since this is all floating. So the solid state relay is a very reasonable and relatively cheap way of being able to accomplish cathode switching or cathode keying or cathode modulation of this system given an input. So we need to give it some signal, some switch signal input in the region. Well, we can see here what it says. Let's take it will input from 3 to 32 volts. And on the output side, go back to here. So on the output side, that's the 2 leads at the top. Those high voltage leads feed directly to the cathode of the tube. And we can attach an ordinary BNC cable on the front here, and that then goes to our control system. for the modulation, which I'm going to come on to in a moment. So that's a solid state relay. The other was really inspired from what Eric designed and built when we did the work, particularly towards the end of the audio modulator bay work that we did in April last year, and then subsequently some of that work that we did prior to the conference and after the conference. Eric designed a Mercury wetted relay modulator for the audio bay system there, and I decided to also try that out on my system. So what you see here is a obviously much simplified research version of Mercury wetted relay, although it works quite adequately. We see 4 Mercury wetted relays. The reason they are standing upright like that is that is the orientation they have to be. So the Mercury pool basically is in the bottom, the relay contacts are at the top, and they have to stand in a vertical for normal operation. Nominally they are rated at their switching is about 12 volts. They need about 30 to 40 milliamps to switch them, and their contact rating is in the region of about 1 amp up to the line cycle voltage. So they're relatively small, but they are perfectly adequate for what I needed here. They are connected in parallel through a series power resistor, so that to equalize the switching between them, so that we don't get nasty differences in voltage on one side or of the contacts, or 1 or 2 or 3 of them. And then finally to the 2 outputs. So there are 2 sets here. They can be used in parallel, or they can be used in 2 places in series. And then we just have I put some TVS, back-to-back TVS diodes there to basically make sure we clamp the voltage so it doesn't exceed the line cycle voltage of the Mercury wetted relays. Those have in turn to be quite important, particularly before I had the spark gap safety device that I showed earlier on the power supply. Before I had that, and if the sink gets out in the drive when you're setting this thing up, then these TVS clamping diodes, they basically prevent nasty pulses going back and shorting out the contacts and effectively welding them together. I had one of the devices early on in the testing where it took a nasty backlash off of the coil. I didn't have the safety spark gap there at the time, and it ended up welding the contacts of one of the Mercury wetted relays together. Fortunately, I bought these as a job lot, so I had 10 of these, and I could able to replace quite easily, realizing that I needed to clamp the voltage and also then introduce the spark gap on the power supply. These are driven in the same way, so we can see on the left here there is a B and C connectors which go to the control unit, and I've arranged those so that they can use the same drive as the solid state relay. So 2 different types of modulators, both of them work actually equally as well. The solid state relay is somewhat easier to set up and use because of the 0 voltage crossing. And of course, with the Mercury wetted relay modulator, I mean, we can switch that at any time. So we could actually potentially switch that at any point in the line cycle, whereas we don't have that degree of freedom with the solid state relay because of the 0 crossing detection. So they give different results overall. There's another more close-up view, so we can see the simplicity of how it's put together. So this is the control box. This is the modulator. This is the modulating receiver. So in other words, this is the final amplifier which switches the 2 modulators that I've just shown. So the output from this control unit goes to the inputs of the B and C inputs of the 2 modulators. And nominally, that gives an amplified 15 volt up to 500 milliamp output on 2 channels. And obviously it can just be on, it could be off, or it can be modulated according to the control box. Now this also takes a line input. So you see we have a power lead coming in there, and that is not just for power, that is also for line synchronization. So in other words, it allows us to do synchronization between the cycle coming out of the high voltage transformers. So that is driven directly from the primary side of the high voltage transformers. So nominally the line cycle, and that allows us with control to synchronize our switching onto the line cycle, which is particularly important if we want to get the optimum cathode switching. In other words, if we want to allow the optimum magnetization of the primary, and then we want to open the cathode and modulate just at the right moment, that synchronization is quite key. It also, if you weren't using a solid state relay, it would be critical to get that synchronization right so you don't just keep blowing semiconductors. So this is the control unit. This is a 2-channel. The reason I'm using 2-channel is because I also use this modulation for my longitudinal coherence setup. I have an apparatus which is designed to measure longitudinal coherence in a cavity between 2 Tesla transformers, pancake Tesla transformers. I measure different types of coherence across there. One of the interesting experiments yet to be done on that uses Griffin's 1A21 tubes to measure the coherence across the channel between the 2 transformers. That will be a subsequent experiments coming later in life in subsequent live calls. But going back to this, so this is the control box. So that's why there's 2 channels here. So there can be 2 channels that are coupled or independent, and it's relatively straightforward. So inside of here we have some essentially arrangements of 555 timers, which are triggered and time each other. So we can have a burst length, we can have phase control, and we can trigger it on positive, negative parts of the cycle. And then we can control the number of pulses per second, how long the burst lasts for, and then we can synchronize the channels together or be independent. So it gives the very fine control of the pulses per second. The burst length is particularly important because that affects the period of time that we energize the primary. If we don't energize the primary long enough, obviously the power oscillator won't start oscillating because there's no feedback coming from that system. So burst is actually a very fine control, essentially, of the number of cycles, or from one period of one cycle, a number of cycles with which the system will remain on for. Phase is also very useful because it changes the point of triggering. So phase allows you to trigger the modulation at anywhere within the line cycle. So altogether, this is how it looks. So we have the control box, the modulation control box on the top of the power supply. We have the control unit at the bottom there. They are connected together. And on the far right, we have the SCR control. So that allows us to control the peak power output of the power supply directly, so the peak envelope power. It also allows us to control the level of nonlinear switching. So for example, if I want to run this as a very linear type of power supply, so in other words, without nasty transients or very strongly switched transients, then I can turn the SCR fully up, so it's fully on, and that gives a nice smooth sine wave, and then I can control the level of that sine wave by the variac, which is underneath this power supply, which I will show right at the end. If I want to switch this system as a very nonlinear transient-based system, then I can use the SCR directly. So I can simply turn up the variac to full power and then use the SCR. And the SCR, of course, switches nonlinearly part of the line cycle, and it's very, very sharp. The switching of that SCR on the transformers can sweep thousands of volts negative when you actually measure it. I showed some of those waveforms in 2023 ESTC. Ordinarily, you wouldn't want that in a power amplifier or always on amplifier, but in a research system where you are exploring the nature of the discharge, the transient system is very, very useful. So how does it look? Well, that is the full extension of the Golden Dragon. So it's not only the first half of the Golden Dragon, but it's fully developed Golden Dragon by using cathode switching. It's about 25 to 30 centimeters tall. Nominally, the power supply is running at this stage at about 3 kilowatts continuous power, and that discharge is developing somewhere between 6 to 10 kilowatts peak envelope power. It's a large discharge. It's very hot, and the fine detail there, you have the front legs of the dragon, you have the rear legs of the dragon. It's a very, very nicely developed, and you get that directly as a result of the modulation. So if you take the modulation away and just run it as CW, then you lose that second half. So that bottom half of the discharge disappears, and you just see the top section. Now, the other also advantage of using the modulation is the total input power. So when you are just pulsing, so let's say that we set this to pulse at, say, 10 pulses per second of within just one cycle. So one cycle, it's allowing the primary coil to be energized just through one quarter cycle, and you're allowing that burst to be on for just one cycle. If you set it up like that, then in effect, the amount of power that you're drawing from the line supply is very low. So the average drawn power goes down to literally just about 1 to 200 watts. And yet you still get a very developed discharge. This discharge isn't that situation. I'm going to show in the next one what happens when you take it down to very low powers over very small burst lengths. This is a relatively long burst length at quite a high input power to get the full development of the golden ratio, or Golden Dragon, as it's now called. Just to remind, the Golden Dragon is basically a fractal discharge, which is expanding at the golden ratio. That's something that I covered in a great deal of detail last year at ESTC. Okay, so this is what happens when you turn the burst right down. So in other words, it's now very short and sharp. The whole thing straightens out considerably, and it becomes quite a bit longer. This is about 12 to 14 inches in length, and we can see, you can't really easily see, but the meters, the needles have gone right down to the bottom on the meters. So in other words, the average plate current and grid current is much lower than if you were running this in CW, which is another advantage, of course, of running the modulation. This is being run using the solid state relay as the cathode modulator. This is now switched over to the other modulator. So this is, I'm just going to give a sample of here. There are a lot of different types of discharges, but for this live call, I will just give a sample so that we can, the presentation is not too long. This is now moved over to the Mercury wetted relay modulator, and we are switching this over one cycle. And again, the result has opened out. It tends to be much hotter. This is a ton. The power settings remain the same. So in other words, I haven't changed the power supply settings between the solid state relay and the Mercury wetted relay modulator. We can see that the needles on the meters are still very low. if this were running in CW mode, the plate current, which is on the left, will be about half there, which will be somewhere around about 1 to 1.5 amps. And the grid currents will be somewhere around about 150 milliamps. Now those needles have fallen right down to almost zero. They're not actually zero, but almost. We're bearing in mind that these are thermometers, so they are also somewhat nonlinear in their scale. This is a tungsten electrode on here rather than a copper electrode. The advantage of using a tungsten electrode is it doesn't wear away, it doesn't eject parts of material when it gets hot, and it also really emphasizes the hot spot. So in other words, if you compare it to this here, it's not as bright. So one characteristic you see of using the the mercury rated relay is it forms a very, very bright light, like a bright sphere at the bottom here, which you don't get with the solid state relay. Although you do get a much more open. So the solid state relay tends to give you very high and tall discharges, whereas the mercury rated relay modulator tends to give you an opened out. Again, here's another example being modulated. And this is what you get. Nothing's changed, but now I've stopped the modulation and I just run it CW. So that's now the output. The whole thing is opened out. There are many, many primary and secondary tendrils. There's a great deal of detail in the discharge, but that's now running CW around about 3 kilowatt input power. So I didn't change the power settings across this. Obviously, I'm giving a summary here. There are so many different effects and different rates of modulation, different burst lengths. There's all those kinds of things to explore in this. I have done a lot of that exploration already, but I'm just really giving a summary here. When I give another detailed presentation on the Golden Dragon, maybe when Aaron has the next ESTC, or when is the appropriate time to do that, then I will go into a lot more detail about the type and form of discharges and how they change for the various modulators and the various modulation rates. So just as I said previously, just to give the final overall view, we can see the variacs that are used underneath to power. It's a 5 kVA variac, the large one, which I use to run, ultimately control the input to the power supply. And there we have everything with the measurement equipment below, a nice Tektronix 545A. I like that era of measurement equipment from the 60s. Is good for it. What's great about that era of equipment is it can sit there and it really doesn't mind the intense dielectric and magnetic induction fields given off from the system. It just sits and it does its job. Whereas if you try to use more modern test equipment, it really doesn't work very well. It crashes, or screen goes white for some reason, or it suddenly turns off, or something like that. So it gives you a perspective of how the whole measurement setup looks. On the left there is a pre-amplifier stage. So on the left, you see on the far left of the bench, there is that's a pair of 3 500s Zs, and it can also take a pair of 4 400As. That is essentially a driver stage. So it's a driver that can be used with the GU5B to drive it directly as master oscillator driven. So in other words, not as a power oscillator. Here, I'm using it as a power oscillator, but the GU5B can also be driven with the master oscillator. And this unit basically takes an input from an amplified signal generator, say about a 5 watt input. It drives those tubes, and those tubes can then drive the power output stage. We will obviously be developing something more sophisticated with the push-pull GU5B development. I'll just say a little bit about that now. When Eric and I were working with the GU5B over the last year, we suddenly saw the potential to be able to build a very powerful, very finely designed and developed push-pull power amplifier. So nominally 20 kilowatt peak envelope power. And that would of course take us into a whole new dimension from here. At the moment, this is a single-ended, single tube. So it's basically working essentially with half the cycle, whereas the push-pull design we're now working on essentially will use both halves of the cycle. So that's going to open up a whole new dimension in terms of the amount of power that we can push, and also the type of effects that we can generate. And that system will be that system will not be a power oscillator. It will be driven from a master oscillator, probably with a pair of 400As as the drivers for the GU5B.
Yeah, it'll be a pair of the GU5Bs, cathode driven by a pair of 4-400As, which will be in turn driven by a pair of 4-65s, which will be driven by a pair of 6L6s, which will connect to whatever the source of oscillation is. So did you get my last letter yet?
I've just received the letter today, so I have not had a chance to review it yet, but I just received it today.
That'll have it'll outline what's necessary to have complete, absolute control over the formation of the discharge.
Excellent.
So, and then I got more letters to send you on overcurrent protection and flashover protection. I mean, it could go on and on and on.
That's okay. We're going to take it as long, Eric, as we need to.
It's got a couple of questions.
Sure.
For one thing, I noticed that the microwave oven transformers, the core is hot. Is that correct?
Correct, yes. The core is hot.
Yeah, that can't be done for a commercial unit. Is it possible to not do that, or will it cause a breakdown in the transformer?
No, it can. What I've done in some power supplies that I've used in the past is I actually disconnect the negative end of the high voltage from the core, and then the core can be grounded, and then it can be run as a normal transformer. It's possible to do that with a microwave oven transformer.
Okay, and you've never had a problem with it doing a burn down because of?
No, it's fine. Okay. I mean, you only get to a problem if you can put two of them in series like that, but you can't put three in series. So if you put three in series, obviously now you have too much overall potential to the primary. But two in series is fine.
Yeah, or Y connected in general.
Or Y connected, yes.
Yeah. So series is star and parallel is mesh.
Yes.
So Y is star and delta is mesh. So it depends on the phases and what have you. Now, what I have recently, the revelation I had, because I do not like using any solid state devices anywhere in this stuff for obvious reasons.
Mm-hmm. And
in Aaron's unit, the cathode modulator was conceived to use MOSFETs because of convenience, in that defined vacuum tubes that work at low voltages and high currents is unlikely, but I did find the right vacuum tube. So that means that I do not have to fool around with MOSFETs. And so the tube is an outgrowth of what's called the 6AS7G, which is a double triode that's made to work as a DC regulator in regulated power supplies. There's one version, it's called the 6528, that can handle over an amp.
Really? Wow.
Current.
That'll be ideal.
And with both units in parallel, the transconductance is 95,000 or 95,000 microsiemens to be technical about it. So basically, one of those will work as a cathode modulator for the IMAC tube configuration. That's the next stage in Aaron's unit, and quite possibly I think a pair of them will switch the GU5Bs without any problem. So they have a maximum voltage rating of 400, and they have a peak current rating of about 3 amps. So that's the switch tube. So I don't have to fool with MOSFETs because I'm not familiar with them, and I would have to have a laboratory situation where I can determine, their curves and all that kind of stuff. So now another question I had is, it appears that because you're not using DC, you're still using AC. Basically, what you're using is AM. So you're not in the CW mode. That's AM at the power line frequency. 100% modulated AM. So you have synchronization capabilities. So can you do it so that you have a contact closure once every 5 or 10 cycle peaks? In other words, you don't have to do it by every one, but you can synchronize it so that after 5. Okay, so then you're starting to get a simulation of the DC, but you're still stuck with the line frequency. So it's too bad that you don't have motion of this stuff, but this Zoom call thing doesn't allow a lot of. I really want to get this noise that we created in the mine when we picked up that earthquake out, because it's supernatural, but there thus far has not been a means to do that. Maybe get it on the website or what have you. But
well, that's what I do is, I mean, when I take the videos, I put them up to my YouTube channel and I put them on the website. But I don't know if there's a way. Is there a way, Aaron, that we can actually show video on these live calls? I don't know whether it's possible with Zoom.
Yeah, I don't know about video. I know I tried even audio. I tried in the past where I was playing it like on a phone, and the phone speaker was going to my laptop microphone, and it still cut it off.
Really? Okay.
So it is technically possible, but you basically have to create a virtual video adapter that records your screen. So it's, instead of playing the camera video, it's using your screen as the camera. It's a pain from a technical point of view.
I do have some type of, I just took it to my shop the other day. It's an adapter that can actually go in a second laptop, and then it feeds through. And if I connect it to this laptop, it interprets that laptop as a camera. But there's some way to do it. It just requires a little bit. There's some hardware specifically for allowing that. I haven't messed with that, but I know Eric, the video guy, knows how to do it. I could probably ask him what setup I need to do in order to.
Okay. Maybe it would be useful to have that facility in the future.
One thing we can do, because this goes on YouTube, is just insert the recording in YouTube.
Yeah, that's not a problem. Yeah, if I have it, I can just splice it right into the.
Yeah, that seems like the easiest way to go about it.
Yeah, indeed.
So in my mind, with this, wireless specialty apparatus company concept, is my mind is somewhat fixated on creating a commercial version of this that is electromagnetically compatible, it's FCC regulation compatible, it's reliable, and it's safe. And I think that that may be something that sells, but that's the route that my mind is going with it, in my peculiar way of looking at things.
Eric, speak a little bit about the power supply that we're going to use for the push-pull GU5B, because that's also something special.
Yeah, that's going to be 3-phase. The nice thing about 3-phase is the power is no longer pulsating, it's continuous. So you don't have to use that big, massive series inductance and a massive bank of capacitors. It's become fashionable, like a bunch of other aberrant things, to load things up with large banks of capacitors. That's all fine and dandy
Yes.
until you get a flashover.
Indeed.
And you get a flashover in the tube, you know, and all those capacitors dump into it. Well, you know, you can kiss your tube goodbye. So
Indeed.
polyphase, you don't need that. Not only is the power continuous, but the output voltage or electromotive force is the peak value and not the average value of the sine wave. And you don't have all these complications of when you take the load off the power supply, the voltage sails up to peak value when you're normally operating at the average value. So, and of course, the transformer utilization factor virtually doubles. So you can get twice as much power out of the transformers approximately as you can with these microwave oven configurations, which are basically half wave and are very difficult on the transformer. That's why the transformer core has that little welded spot. Have you noticed that?
Yes, of course. Yes.
Because that's the self-inductance gap, so that the DC component through the winding doesn't saturate the core and then cause the primary to burn out.
Yep.
So you don't need that with polyphase, you know, 2-phase, 4-phase, or whatever 3-phase operation. Then you can eliminate that because there's no DC flowing in the core, and then the transformer utilization factor skyrockets. That's one thing, you know, the common radio rectifier, you know, like the 5Y3, 5U4, or any of those, is a push-pull arrangement that uses 2 diodes and a center tap transformer. But the fact that the DC is flowing in one winding and then opposite phase it's flowing in the other winding kind of loads up the core. So basically, if you use a bridge rectifier, you would get the full utilization factor of the transformer, but which is about 98%. But with the push-pull arrangement, you only get 63%. So I found by using bridge rectifiers and the proper secondary voltage accordingly, to get almost twice the power out of the transformer by using 4 diodes rather than 2. I think that's one thing, like many things, that has become forgotten in the techie world of today.
For sure.
So that kind of, so that's my questions.
Good. Okay. Thank you, Eric. That also, I think, covers what we can say for now about the GU5B push-pull. I mean, we are still really very much in the preliminary, at the beginnings of the design. I will review your next letters, Eric, and just keep the letters coming. We'll keep going with the design and keep discussing.
Yeah, and Griffin has the schematics for the lower end of the power level of the system.
That's right.
Up to the 4-65s. Plus, we've come up with another type of RF transformer design that is yet to be built that may allow the use of these ferrite cores, which technically are incapable of transformer action. So that's in my research, I found that ferrite cores do not really make transformers. They make inductors. They have self-induction, but they don't really have mutual induction. And you might be able to get away with that with a power transformer, but you sure can't get away with that with audio or radio frequencies. And the audio people do not like audio output transformers that are wound on ferrite. They just don't sound right. Indeed. So Griffin has this material. In fact, Griffin's got all kinds of schematics that I've been working on for all these different amplifiers and modulators and oscillators and things, which are actually quite extensive. And I'm hoping that these things can be made commercially available, you know, either as, entertainment or music performance or scientific or what have you. They're kind of multi-purpose, and they're going to be based on standards so that it's not a bunch of incongruous equipment, but everything can snap in place in a modular way. So we're making pretty good progress on that.
Well, that's also something worth just to add on there. That's something important worth considering with the GU5 push-pull final power stage. Is we are also looking at building that in a modular and portable fashion. So
yeah, it's going to be like a military or a rock concert type design where everything's got to be rugged, it's got to be transportable, Everything has to come completely apart. That's the way I designed Aaron's system. Every unit can be completely disassembled without having to cut any wires or any of that. Every unit is basically self-contained. It's got to be, you know, a one-man lift. It can't be something that people have to struggle with out of the rack or so. So at any rate, Aaron has the manifestation to that. So now basically we're taking, you know, to the next power level. We're going from the 2 kilowatt to the 20 kilowatt.
Absolutely. Look at 20 kilowatts peak envelope power.
No, it's 20 kilowatts average power.
Oh, your average power. Oh, well, that is
yeah.
something. But then that's going to be enormous peak. I mean, that thing should be spitting fire, as you say.
Well, what's going to be interesting to see is how far can this coil be pushed before it does the big flame out.
Yes.
And the other thing that'll be required is to reduce the size of the counterpoise so that it can be properly insulated and isolated from human contact. And there is a mathematical or geometrical ratio of the high side capacitance and the low side capacitance to be optimum. But you have to know the natural or the characteristic capacitance of the coil in order to calculate that. But that factor is very difficult to calculate from the physical dimensions, so it's going to be experimental.
It'll have to be experimental.
But I figure probably, you know, the counterpoise capacitor, you know, probably would be about 1 foot in diameter, and it would be on, you know, raised insulators, high voltage, and then the so-called primary coil and what have you would be bigger around and would have a much higher magnification factor so that it wouldn't have to be so close.
Yes, indeed. Actually,
So
that's a good. Actually, it's a good point that you raise. Actually, because I didn't mention about this lab setup I hear. Often I run that with a counterpoise, but this is not shown as with a counterpoise as a reciprocal coil, which forms a counterpoise or a cavity with this system and allows it to run in a balanced configuration. Eric, you might say a little bit more about why counterpoise is important in a Tesla coil system.
Well, the main thing is remember, Tesla designed this stuff to transmit.
Yeah.
And you're basically creating something that could basically wipe out, you know, all electronics in an entire neighborhood if situations are unfavorable, particularly, you know, with this multiple Y connection, which is spreading like a disease throughout the electrical systems of the world. So basically the Tesla transformer has to be electromagnetically or electrically self-contained. It cannot rely on earth terminals or anything like that, or it's going to transmit. So one way to do that, you know, is with 2 coils out of phase. But when we experimented with that, we found that unfortunately that halves the electrostatic potential at the terminals. And being that this is a spark generating coil, that's not desirable. Mm-hmm. But when you're doing the cosmic light bulb type work, then you want the 2-phase coils. Yep. In which case you need no counterpoise or no connection to the earth or any of that, because one coil serves as a counterpoise to the other, and the system is completely non-transmittable.
It's naturally balanced.
Yeah. And the other thing is these things have to be confined within, you know, a normal frequency spectrum, and it has to have a frequency stability, you know, of the FCC regulations for this type of stuff is pretty tight. You can't just be wandering all over the band. And so before anything like this can be sold commercially, it has to meet all, well, I mean, nobody really cares anymore. That's why this gangrene energy is out of control, but I don't want to contribute to that. And if somebody wants to make trouble, you know, like if you end up interfering with some Air Force communications channel or something, well, then everybody's going to get their butt burned. We don't want to be the ones to cause that to happen. Leave that to Styro Pyro.
Indeed. which I have to say does most effectively.
Yeah. So you have anything to add on this, Griffin?
Not really. I mean, other than
Okay.
the method that you were describing of using two coils, that is basically the early 1890s Tesla oil transformer design that I was mentioning earlier. And from my personal experience, that operating a coil in that manner, especially in something more erratic, say a spark gap powered setup, you could operate an AM radio within the same vicinity or within the same room with a coil of that configuration, since it's basically closed upon itself, doesn't necessarily radiate.
Yeah, that's basically the objective. That's what was applied to the multi-wave oscillator design, which basically the design converted it from electromagnetic terrorist tool to something that's safe to not disturb your neighbors. You could actually operate an AM radio near the thing and not have it jammed out. That's kind of what we're after here. So the one thing I want to point out about the oil box transformer, as I call it, is that has the side advantage of so we have this this concept of these electrostatic rotating apparatus, what I call the Trump motor, after John Trump, who had duplicated a lot of Tesla's ideas after he had exposure to the patents after Tesla died. That has to operate at a voltage of about 60 to 100,000 volts, but the modulator only puts out about 2,400 volts. So there has to be a resonant line, which are known in the vernacular as analog computers by my prior videos and what have you, is this oil box transformer will double as the inductors required to step the output of Aaron's modulator from 2,400 volts up to 60,000 volts to do this. So this has kind of dawned on me the other evening when I was musing about this stuff. So now I'm more interested in that device than I had been previously. And also there's a lot of circuit design that's got to go with this thing to get the pulses we want and all that. So this is going to be another exploratory adventure, but I'm sure it'll turn out to look and operate quite nicely. One thing that occurred to me with the Tesla converter, the problem is what do you use as the switch? And then lo and behold, a car radio vibrator is perfect for this. It's got rugged contacts. It can't be burned out, so that you can operate the thing at a high level instead of using sensitive high-speed relays, which are only good for 1 milliamp. Now you got something that's good for an amp. And basically the only modification you have to make of the vibrator is you have to disconnect the contact that breaks the coil circuit to make the thing oscillate and feed AC into the vibrator coil. So there is a way with somewhat readily available components to start building these Tesla converters without having to use exotic sensitive relays that as soon as you get a big signal, they're burned out. And that's the only one you can find. So that's kind of a new idea that popped up. So that kind of empties my mind on the subject. So,
Well, we're about hour 48 minutes into the call. You want to jump to some questions and maybe keep it to 10, 15 minutes, something like that?
yeah, and I want the questions. I don't want to get into exotic theories of, whirly-twirly cosmic phenomenon or flat Earth or chemtrails or free energy secrets, but keep the questions related to what it is that we've presented, please.
So very, concise, short, quick questions and answers, I guess. So if you got a question, there's a reactions icon at the bottom of your screen. It looks like a little happy face. And if you click on that, then you'll see a little pop up with some icons that say raise hand. And then, and please don't unmute yourself and just start asking a question. Wait until I prompt you to do that. And when you unmute, go ahead and say your name, where you're from, who you're addressing the question to, and what your question is. Okay, Mark.
Yes, sir. I'm Mark. I've asked a question before. I was in Israel at the time. Now I am from Sweden. And can you hear me?
Yeah, I'm just looking for your You have a video up? I was going to put you on the screen, but maybe
I
not.
do not.
Okay. Yeah, go for it. We can hear you.
Okay, so I have two questions. So the first one is to Eric Dollard. It's about the zero sequence current. And so if I have a diode that creates a nonlinearity and it generates a DC type zero sequence current, how can I achieve this without using the diode? I'm looking to make a rectifier that doesn't use any diodes.
Well, you're going to have to use one type of nonlinear component or another, whether it be a saturable reactor or there's no way to do it with linear devices. There has to be something that distorts the waveform. And the rectifier diode is probably about the best way to do that.
All right. Okay. And the second question is, if you would actually be able to cut this out from the YouTube release, it's about the Trump generator, Trump motor. Aaron, would you be able to cut this out?
It's possible, but I don't really want to. So I have
Okay,
to go in.
well-
I would have to go in and edit it and have this video rendering hijack my computer for several hours while it renders. I got to add title screens to do it anyway, but I would have to hunt. So.
Okay,
What was
well,
the question, Aaron, what was the question? It was garbled here. What
Sounds like it's related to the Trump generator. I don't think there's really many secrets.
Okay, I'll just ask. So I've built one, and I find it really strange that I've been able to light a small low voltage LED off of just 100 volts on the plates, and at about 2000 RPM, and without any vacuum. I did have a very close gap between them, and that's why I had to go down to 100 volts. I had just 0.1 millimeter gap. And another thing is that I noticed that the closer you get the plates together, the higher the modulation factor that can be achieved.
Well, it sounds like you're making good progress. Keep it up.
Indeed.
So that sounds normal because you just mentioned thousands of volts on it, and
Well, you can scale it up. I mean, obviously, if you arrange a capacitive system there where there is more space between the plates, you will be able to scale up the voltage. And as you scale up the voltage, essentially, you are scaling up the overall output. Essentially, it goes with the voltage squared. So the more voltage you can put your system up to, the better and better it's going to get, and the efficiency is going to become higher and higher.
Right. Okay. And just one more follow-up question real quick. Something I couldn't figure out is how do I calculate to pick the right inductance for the output? Because it requires the inductance. And I just picked the highest one I could and got some results. But how do I do that? How do I pick one?
That, I believe, is in the presentation that Aaron and I did jointly. I think that subject is covered. Because you have to set the inductance for the effective capacitance, but because it's a nonlinear relationship, you might have to do it experimentally. But the inductance is going to be very, very high value. So it's not going to be an easy one to come about. It's going to have to be kind of a high voltage type of inductance.
Okay. Yeah, I guess that's it. Thank you. Thank you very much.
Okay, thanks, Mark. In that Trump generator presentation, John G. Trump, that was 2022. That was year before last, 2 conferences ago.
Oh, I got all of them. I've watched
Okay.
through the. I've got both the Trump generations by Hakasays and by Eric. I got all the notes. I got everything.
Okay.
Thank you.
Let's see. Somebody with phone number that starts in 617. Go for it. They're asked to unmute.
Hi there. Can you hear me now?
Yeah, I can hear you.
Yeah, this is Michael Mueller from Worcester, Mass. I just wanted to know if I could write down Adrian's YouTube channels URL?
Yeah, my website is aminnovations.com.
AM Innovations.
Aaron, would you put it into the chat, please?
Let's see.
And
AM,
if you go to YouTube and
is
you
it
search,
AM dash AM hyphen?
yes,
Yeah.
yes, am-innovations.com. And if you go to YouTube and you just search for AM Innovations, then my YouTube channel will come up.
Very good.
You're
Thank
welcome.
you. Thoroughly enjoyed this.
Okay, thanks.
Thank you.
Okay, let's see. Any other questions? You can hit the reactions button at the bottom of the screen. It's the happy face, and you'll see the raise hand. Let's see, and somebody had a hand raised. If I accidentally put it, okay, let's see. James Melendez, go ahead and unmute yourself. Yeah, go for it, James.
Hi, this question is for Griffin, I guess. You've got the Marconi style antenna up on your roof, and you're measuring interference and things like that. I was just wondering, like, I know that your objective is to get that kind of lower frequency stuff. Are there any plans on maybe utilizing spectrum analyzers and catching the microwave higher frequency end of this gangrene energy? Thanks.
Well, in terms of spectral analysis, I mean, I've found that the interference does extend far into the upper broadcast bands, even further into higher frequencies, but not necessarily anything within the microwave realm. I do have a spectrum analyzer currently, which does need some tentative work, which will ultimately give a visual spectrum of the level of interference. So that's still a work in progress.
So let me point out that during the next work episode here, I have a military disc cone antenna that's going to go on a mast out in front of the building. And then a low loss coax is going to bring that into one of those fancy Hewlett-Packard spectrum analyzers from the 60s, which goes up to 13 megacycles or 1300 megacycles per second. So a disc cone is a very wideband antenna. So even though this one is actually designed for the 50 to 100 megacycle range, it still will pick up. So we'll be able to do a presentation of a wideband representation of or presentation of the gangrene energy that is so out of control here that it jams out even my CB radio. So that'll be upcoming.
Great. That sounds great. Thank you.
Thanks, James. Okay, looks like Stoyan. Go ahead and unmute. Stoyan, you should be able to unmute yourself. I'm clicking. Okay, there you go.
Do you hear me?
Yes, just fine.
Because I don't see my question is, I wrote this. Tesla in his patent 787-412 claimed that he measured velocity of 471 and 240 kilometers per second. That is about 1.57 times the speed of light. And interesting, it is just a half of speed of light multiplied by p. I don't know, did someone succeeded to measure this kind of speed that obviously is radiant longitudinal waves?
You know, that's been measured as the propagation velocity on the Tesla transformer itself, but Tesla's mention of that it's not a velocity in the normal sense. It's kind of an effective velocity of propagation through the spherical geometry of the Earth. And then by my own research in the dimensions of this stuff is there's actually no velocity involved here in the common knowledge or way that people think of velocity. It's no longer in miles per hour, it's in per mile hours. So it can no longer be expressed as a velocity. The propagation is in another set of dimensions that has not really been understood. But when you get into advanced transformer theory, like in Bewley's traveling waves on transmission system books, and work out the dimensions, you find out that we're not dealing with a velocity anymore when we're dealing with so-called Tesla waves. We're dealing more properly with a counter velocity. I gave a rather lengthy presentation on this topic in I believe the title of the presentation was Electrical Transmission and Multiple Coordinate Systems. And I demonstrate how the normal or customary definition of velocity is no longer applicable, but now we're dealing with another set of dimensions.
Yeah. Trying to pull the cover up on that presentation. For just a second, let me show it real quick. Let's see, share screen. So on emediapress.com, here's this electrical transmission and multiple coordinate systems. And this presentation, that was, I don't know, 8 years ago or something like that. It's been a while. 4-hour presentation, 301-page PDF. And this is the one that Eric is referencing.
Thank you.
Okay. Any other questions for you? Or? Okay.
No.
Okay, thanks. Let's see. Any other questions, or should we go ahead and wrap it up? 201, doing pretty good. Let's see. Okay, well, if there's no more questions, let's see. The website, let's see, Eric's website, again, ericpdollard.com. And there is a donate link on there. And again, it is a 501c3 nonprofit corporation, and all the donations go to help funding all these type of projects that's been discussed. Adrian's website is am-innovations.com. Griffin's is griffingBrock.com. My main website is emediapress.com. That's where all the presentations are. There's a lot of blog posts and announcements and stuff. But also, if you want to communicate with Eric directly, we'd like to get some conversation going at energeticforum.com. It's free to join. If you join, and if you cannot post or see attachments, email me at info@emediapress.com, and I'll activate your membership right away. We have to update it so we can get the memberships going automated with the more recent spam blockers and all that kind of stuff. It was so overwhelming in the past that we just made it where people have to manually request activation so that we know that it's a real human being. And so you can post in the Eric Dollard forum or anywhere else appropriate in there if you want to address him directly, and he knows how to go in there and respond to those. And I'll subtitle these websites in the video itself once it goes on YouTube. And I'll try to get this posted here in the next couple days. I don't think I'm going to edit it. I'm just going to add some title screens, get that rendered, and just upload it. 4 weeks from now, let's see, 1, 2, 3, that's the 9th, and then 16th. So about March 16th. Okay, that's 4 weeks from now. So that's basically middle of March. If we want to tentatively look at doing another one of these group calls 4 weeks from now, March 16th, noon Pacific time. And depending on my schedule and stuff, I'll talk to Eric about, an Eric Dollard call. So where if people want to, just ask him questions about, whatever. We've had a little bit of feedback on that. Any final comments or anything before we end the call?
I guess I'll do one. Is the person that was asking about the Trump motor, if they have anything, any questions or whatever, I do have some experience constructing. So if they have any questions on that. I also want to thank Mr. Sarg for his questions, because I've read some of his work, and it's It's interesting material, so appreciate the contributions.
Okay. And what's the easiest way for somebody to contact you if they want to?
Just email me. I believe my email address is on the conference links.
On the conference links?
Yeah. I'll send it to you, and then you can put it on the doobly-doo.
Okay. And you're also in energetic forum too, right?
Not very regularly, but yes, I'll answer questions on there too.
Okay. So anybody can address Hakasays an energetic forum. Any final comments, Eric?
No, I think we're QRU.
Okay, sounds good. All right. Well, thanks everybody for being on the call. I'll get this up as soon as I can, and we'll see you in about 4 weeks. And also, if you go to emediapress.com /energy times, that's a free newsletter, and that's kind of the main one where I put out most of the announcements for these kind of calls and anything else going on. So I'd highly recommend joining that Energy Times newsletter. You'll get a double opt-in request coming in your email that you can click on to verify you did indeed request to be on that mailing list. And other than that, we'll see you all in about 4 weeks.
I do have one question.
Yeah.
Is the first installment of the Tesla 4-phase book out yet?
Tesla 4-phase book.
One that Griffin had
The
transcribed?
polyphase pamphlet. Yes, so that has been published.
Yeah, that's available as a PDF, and it's also on Amazon. Here, I'll bring it up real quick. Here, just a second. Let me do a screen share, and then yeah, that's it. Yeah, so if you go to YouTube, I mean, if you go to, what is this website? Amazon, and you type in the search bar Eric Dollard Polyphase, you'll see this book right here. This was recently published, publication date December 1st, 2023. It's a little 6x9, it's about 100 pages. You can see the front and back cover. The back cover here gives a little synopsis from Eric on what that's about. And so that book is available here. And then let's see, emediapress.com. Emediapress.com in the top right, if you just type in polyphase, then you will see this, and this is the paperback version. So it's also available on Kindle on Amazon. Kindle doesn't seem to be that popular. People either want the paperback or they just want a straight PDF without having to use all the Kindle application and stuff. So if you want the paperback, go to Amazon. If you want the ebook, it's available on emediapress.com. And anything else, Eric, that you want me to point out before I?
Well, right now I'm working on the second volume, so I think by the time that Griffin gets here to scan the thing in the spring, that will be done. So
Okay.
basically, this is all from the presentation that I gave, and which this material is very difficult to present in one of those fashions because it's gets very, very detailed, very, very complicated, and I can't keep it all in my mind without any notes. So basically, I use my drawings as the priming element for my mind, and then I sit down and write up the presentation. So that's presently what I'm doing now. It'll take about 2 years to completely write up the entire presentation, but the second volume should be out. I would imagine it'd be out by the summer.
Okay. All right, and we'll definitely be announcing that on the calls and the newsletters and everything. Hey, Stephen. See you logged on at the last minute. We're about to end the call. So, okay, we'll see you all next time. And thanks for joining the call, everybody. And spread the word. And please help out with anything you can. Let your friends know. ericpdollar.com, the donate button. PayPal, Bitcoin, or check or money orders, and that's what's helping us to fund the projects on this side. So I'll see y'all next time.
Thank you, Aaron.
Hey,
Okay,
everybody, have a good weekend. Take care.
Thank you.
see y'all later.
Feel free to call anytime, Stephen. Catch up.